Alright, sorry the last video cut a little bit short. Now, I'm not going to do all the examples. The ones I skipped so far are the ones I think you should be able to do without my help. This one as well, but I did it anyway. Just recognize you're using the power and the chain rule. Okay, and that's your answer. If you can deposit, go ahead, do it. And now here, you've done it before, it's been a while, and it's asking for, we have the x value at 3, okay? And we have f of x over g of x, so you have to use the quotient rule. Okay, so plug in everything into the quotient rule, and you'll see the answer just appear. All right, and there's your quotient rule. So we have k prime of x here using the quotient rule, and just plug in whatever g of 3 is right there. Okay, and so on and so forth. F prime of 3 is right here. Okay, and you should end up with that. And there's your answer. Okay, here we have a graph, two graphs. We have a line, we have 2 points, so we can figure out the slope of that graph using those 2 points. And then we have y equals g of x, okay, which is the curvy graph. Yeah, what it's asking for is, if we have a function here, and we have a product of two numbers, of two functions, what's the derivative of this, okay, and then plug in a -1. So first find the derivative using the product rule, and you would get that guy right there. And keep in mind the derivative of e to x. E to the x is e to the x. Okay, how do you find g prime of x at x equals -1? Okay, here's x equals -1. How do you find the derivative of this graph right there? Well, it's the slope of this line. So find the slope of that line, and then you can plug everything in. So you got to plug in the e to the -1 when you're done finding the slope. Once you find the slope, plug it in right there. Okay, let's just put the slope there. Okay, e to the -1 again. And what is g of -1? What is the y value at that point right here? What's the y value? The y value is 3. Okay, so find what m is, you plug it in there, and then finish that up. So you got 1, 2, 3, 4, 5, 6. 1, 2, 6 over 2. So the slope is 3. And that's hilarious. I just completely made that point up. Wow, good going, Rivera. There we go. We got 6. And negative. Okay. Okay, e to the -1 gives you 1 over e. So you have -6 over e. Same thing on the other side. 3 over e. And you end up with -3 over e. Okay, we're given a function here. It wants to know where is the derivative equal to 1/2. That's what this is asking. So use the quotient rule here to find where the derivative is. Set it equal to 1/2 and then start simplifying. Okay, so I just plugged in. Sorry, didn't plug in. I set it equal. I simplified, and those were my answers. Okay. And as you can see here, you probably nope, you don't have to plug in. There's x equals 0 and x equals 4, and letter D is your answer. Now, if you have more than one option where you have x equals 0 and x equals 4, you would then need to plug it into the original equation. Sorry, no, you plug it into the equation. Yes, to the original equation. Sorry, to find out what the y values are. All right, all you have to do here is plug in 3x minus 2 into the x here, into the x right there, and find the derivative. All right, and breaking it down. Actually, I'll just show you the work. And there you have it. All you have to do now is plug in x equals 3, and you should get letter A. Okay. Check your work and your algebra. Get some practice. For the rest of the derivative practice problems, those are the answers. If you need to pause, go ahead and pause it. Moving on. Okay, the next problem I'm doing is 36. And the important thing to recognize here is we have its position graph. Okay, we have its position function, and it's asking for when the speed is 0. When the particle is at rest is when the speed is 0. How do you get speed from position? You take the derivative. How do you get it when it's at rest? You take the derivative and set it equal to 0. And the easiest way I would do this is to combine them. Excuse me. Is to combine them so that you have t squared minus bt minus at plus ab. You know, I just FOILed it out. I expanded it. And now you set it equal, not yet, sorry. Take the derivative, keeping in mind that those are your constants. Okay, right here it's coefficient, right here those are constants. When you take the derivative, they're equal to 0 when they're by themselves, just like they are with AB. So your derivatives look like that. Alright, now set them equal to 0 and solve for t. And there's your answer. Alright, now we have a position graph here, position function. And so, what's the acceleration? This means we have to find the derivative twice. Okay, now we find the derivative twice, particle at a point where the velocity is first equal to 0. So we also need to find where the velocity is equal to 0. Excuse me. So once we take the derivative the first time, set it equal to 0. Okay, once we find that value, we take the derivative the second time and set it equal to wherever the derivative is equal to 0. And the first derivative. And here's your first derivative. Alright, derivative sign is cosine, the derivative of cosine is negative sign, so that sign changes, the minus sign changes, and we're setting this equal to 0. Where is the only place we can have, excuse me, where we can have the cosine and the sine, if you added them up together, equal to 0. It has to be at one of the 45-degree angles. Okay, because if you add them together, one has to be positive, one has to be negative, and you get 0. And which quadrant would you have one equal positive and one equal negative? That would be the second quadrant. And it's root 2 over 2, and root 2 over 2. And those two places would be at cosine equals 3 pi over 4. Okay, so at 3 pi over 4, is where you have sine of t plus cosine of t equal to 0. Now let's take the next derivative to find the acceleration. And there you have it. Evaluate it at 3 pi over 4. Okay, what's the sine value? What's the sine value at 3 pi over 4? Okay. The y value is positive, so you end up with this negative sign over here. Okay. And what's the x value? That's a negative. And this equals negative root 2 over 2. Okay, so when you add these up, you get negative 2 root 2 over 2, negative root 2. And you answered the thing. Sorry, don't forget that. Okay, now what I have been skipping are the, and I'm not going to test you on, the ones that ask you about inverse functions, okay, where you have, excuse me, where you have this inside the question, okay, or any form of f negative 1, that's the inverse of function symbol. And I'm not doing integrals either. Okay, I'm not giving you where you have velocity, you need to find position. I'm not going to do any of those. Okay, so I did skip a couple of straight line motion. If it asks you to go backwards, I'm not going to test you on that tomorrow. Alright, function analysis is important to know. First derivative, you find out where the slope is increasing or decreasing, where the function is increasing or decreasing. The second derivative tells you about concavity, and the third derivative gives you information about the inflection point. Okay, so this one is asking which intervals is it decreasing. So find the first derivative and decide where the first derivative is negative or positive. That's all there is to it. So here's your derivative. Find out where it's 0 so that you can find out where the max or mins are. Okay, and then evaluate it to the left and to the right. So setting it equal to 0. And there's your factored form. My apologies. X minus 7. Sorry. And those are the points where the derivatives are equal to 0. Is where you either have a max or a min. Okay, so I'm going to draw a little number line. There's going to be my 0. 0 does not have to be included in this. And there are -10. Now let's plug in numbers to the left of -10. Just plug in -11. And make sure you use this form when you plug it in. We got a -11 here. This makes this one negative. -11 here makes this a negative. So we have a positive here. Negative times a negative. Alright. Now if we plug in a 0, we need something in between the 7 and the 10. Plug in a 0, you get 10 here. Okay? So you have a positive. If you plug in a 0 here, you get a negative, leaving you with a negative. So everywhere in between, the function's decreasing. What about past 7? Okay, let's plug in an 8. If you plug in an 8 there, you get a positive. Again, here, if you plug in an 8 there, you also get a positive. Okay, so it's positive. So the function does something. It's increasing up here somewhere. Whoa, sorry. How's that? Okay, over here, right here, it levels off. Okay, it's 0, so it's increasing. It levels off here. Then it's decreasing. Decreasing, then it levels off again right here. Then it starts increasing. All right. So from -infinity, so the interval where it's decreasing is from -10 to 7. All right, there's your answer. Okay, here's giving us the graph of the velocities. All right, the graph of the particle's velocity here. Okay, just by looking at the graph without thinking about derivatives, anytime this particle is decreasing is when the speed approaches 0. Okay, well, if the speed is approaching 0, that means it's slowing down. And the two places where it's approaching 0, it has a top speed here going away, okay, and it's going towards 0 right here between J and K. Now also think about what's going on here. Here's the speed in the negative direction getting faster and faster and faster and faster. Okay, right here it turns. Now it's going it's slowing down right here, okay, going towards 0 to the speed equals 0. So between J and K and L and M is where the speed is decreasing. Between J and K and L and M, that gives us letter C. So just keep in mind, anytime you have velocity here, as you go away from 0, you're speeding up. As you come towards 0, you're slowing down. As you go away from 0, you're speeding up in a negative direction, slowing down towards 0, approaching 0 speed as you go towards 0. Okay, what's the minimum value? Now, just find the derivative and find the points where the derivatives are 0. That tells you whether you have maxes or min. Plug in the y values at the end points and at the points where the derivative equals 0. Find out which one the smallest value is. Okay, this shows us where the max or mins are, right? And the x values are where the max or mins are. Now we need to plug those in as well as the two endpoints and see which one gives us the lowest value. When you do that, and hello, once you're done plugging in all the numbers, that's what you get. Keep in mind if you're working this out, why is this all of a sudden positive? Well, I combined the negative here and the negative here. Okay, that explains that. All right, and I only got to this point because I learned from this point right here I was going to get a positive number and then continue to add more positive numbers, and I knew I needed to stop because it's already bigger than that one. And right here it's not as small as -7, and 2 is not as small as -7. Now remember, if it asks you what the minimum value is, it's the y value. Where it is, it's the x value.